Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter Introduction to Atom. In the earlier sessions we have seen different concepts like what is an atom, what is Dalton's atomic theory, and the discovery of certain fundamental particles like electrons and protons we have seen in the earlier sessions. Now, in this session, let us see the discovery of neutrons, how it was done, by whom it was done. Okay, let us see about discovery of neutrons. After the discovery of electrons and protons, it was assumed that the only one particle that can account for the mass of an atom is the proton, because the mass of electron is negligible, isn't it? So after the discovery of two fundamental particles, those are electrons and protons, and they studied about these properties also, they came to know the mass of electron is completely negligible when compared to the mass of proton, isn't it? We have studied in the earlier session each proton mass equal to 1837 electrons mass. So when compared to the mass of proton, mass of electron is very small, which can be neglected. So now the mass of an atom is nothing but the total mass of the protons existing in that atom. So in that way they came to one conclusion that the only one particle that can account for the mass of an atom is proton. Okay, as the mass of electron is negligible, and they came to know as only these two fundamental particles present in the atom. But except in the case of hydrogen, it was found that the mass of an atom is greater than that of the protons present in it. So surprisingly, it became wrong. Their assumption became wrong, except in case of hydrogen. So when they tried to calculate the mass of hydrogen atoms, they were succeeded based upon this assumption, because hydrogen has one electron and one proton. Whereas mass of electron is being negligible, the mass of hydrogen atom is nothing but mass of proton present in it. One proton is there, the mass of hydrogen atom is now the mass of one proton. So it is practically true there in case of hydrogen. Mass of hydrogen is around 1 amu, because there is one proton, its mass is nearly 1 amu. So the mass of hydrogen it is atom also being 1 amu, it is practically correct. But in case of remaining elements, for example, if you see helium, we know its atomic number is 2. So they came to know as helium has 2 protons and 2 electrons. Now the mass of helium atom is nothing but the sum of the masses of these all particles, isn't it? But here the mass of electrons is very small, which can be neglected. Now, the mass of helium atom is nothing but the sum of the masses of these two protons, it should be, as per their assumption, isn't it? Now, the mass of each proton is equal to nearly 1 amu, isn't it? 1.007 amu actually. So it should be 2 amu nearly. But practically, when it is calculated, it is being around 4 amu. Means they got the mass of helium atom greater than the sum of the masses of protons present in it. Not only for helium, except hydrogen, for remaining all elements, their assumptions were wrong in case of masses of the atoms. The mass of the atom is being greater than that of the sum of the masses of protons present in it. Further, it was found that the extra mass is either equal or a multiple of the mass of a proton. So they found that every atom is having greater mass than the total mass of the protons present in it. And also they found that the extra mass is either equal to or a multiple of the mass of protons present in it. In case of helium itself, let us see once again helium. So practically, as per these assumptions, it should be 2 amu, because it has two protons, but practically it was found 4 amu. It is being greater and it is being the multiples of mass of proton. 4 times it is being the mass of proton. So in this way, the extra mass is being either equal to or a multiple of the mass of proton for every element except hydrogen. This suggested that an atom must contain one more kind of particles which should have the same mass as a proton but no electrical charge on it, because by the presence of these particles no electrical charge influence is being seen on the atoms. Already they found that electrons are having negative charge, protons are having positive charge. The total charge of electrons is being counterbalanced by the total charge present on the protons in that atom. Hence, atoms are being neutral. And these third kind of particles might be having mass equal to the mass of protons, but they do not have any charge. If they have charge, what happens? Because of the presence of charge on those extra particles, atoms should acquire that charge. But atoms are being finally neutral in charge. So from this they concluded that there are one more kind of particles than these electrons and protons. Those particles are having same mass as that of protons but having no electrical charge on it. These particles were named as neutrons, as they should be electrically neutral. So based upon their neutrality, those particles are named as neutrons. Experimentally, however, the neutron was observed much later in what is called a nuclear reaction. Actually, these neutrons were discovered so long after the discovery of these electrons and protons. So, these neutrons were discovered in certain special reactions called nuclear reactions. Okay. In 1932, James Chadwick bombarded the element beryllium with alpha particles. So, in that experiment, he found the production of neutrons. He observed that beryllium changes to carbon and thus neutrons are emitted in this reaction. So, in that reaction, he observed the emission of these neutral charged particles which are having mass equal to that of protons. See, certain alpha particles he passed on to this beryllium. Then this beryllium turned up into carbon and releasing neutrons. So, in that way, neutrons were discovered in certain nuclear reactions by the scientist James Chadwick in 1932. Okay, here we use one word, alpha particle. He used alpha particles to bombard on beryllium atom. What are these alpha particles? Alpha particles are emitted from radioactive elements. Radioactive elements means certain elements are being unstable. Their nucleus contains so many protons and neutrons all together. So those atoms will be unstable and they split into smaller atoms. While splitting into smaller atoms, they release a large amount of energy out in the form of these alpha particles and some other radiations. So in this way, from these radioactive elements, for example, uranium, radium, thorium, these all elements are called radioactive elements. Their nucleus are unstable. They will be ready to split into smaller atoms. While splitting into smaller atoms, they produce these particles like alpha particles. Alpha particles is nothing but the bunch of two protons and two neutrons. These four particles together considered as one alpha particle. This also can be considered as helium ions with a double positive charge. Okay, so here if you observe, we know helium atom consists of two electrons, two protons and two neutrons. If two electrons are removed, what happens then? It will be remained with two protons and two neutrons. These two electrons are removed. Then the helium nucleus will be remained with two neutrons and two protons. These particles which are containing two protons and two neutrons together are considered as alpha particles. So as these are containing two protons, they carry 2 units positive charge and totally 4 units mass because of presence of two protons and two neutrons. Okay, these are alpha particles. These alpha particles are generated or emitted from radioactive elements. So about these alpha particles and radioactive substances, we are going to describe in further classes. Now let us see the properties of neutrons. The mass of a neutron is slightly more than that of a proton. Actually, to say, in general, we say the mass of proton and neutron are nearly equal. Sorry, nearly equal. But to say accurately, the mass of neutron is slightly greater than that of mass of proton, where the mass of neutron is considered as 1.674 into 10 to the power of minus 24 grams is the mass of neutron. It is slightly greater when compared to the mass of proton, which is equal to 1.672 into 10 to the power of minus 24 grams. Okay, here if you take in terms of AMUs, then also the mass of proton and mass of neutron generally considered as 1 AMU in the round values. But to say accurately, mass of proton is 1.007 AMU, whereas the mass of neutron is 1.008 AMU. So from this you can say the mass of neutron is slightly greater than that of proton. And by coming to charge of neutron, electrically a neutron is a neutral particle. That means it has no charge on it. It has only mass, it has no charge. And even we can say it is the heaviest fundamental particle. These three particles whichever we have studied till now, electrons, protons and neutrons. These three particles together are considered as fundamental particles of atoms. Okay, out of these three fundamental particles, neutrons are heaviest particles. Okay, in a particular element, the number of neutrons in the nucleus of its atom may vary. Yes, it is one more interesting point about neutrons. So the number of electrons and number of protons in an atom will be same for all the atoms for an element. If we take carbon, if wherever you collect carbon atoms, they will be containing fixed number of protons, that is 6. All the carbon atoms, all the atoms of an element will be having fixed number of electrons and protons in their neutral state. But the number of neutrons may vary from atom to atom. For example, if we take hydrogen itself, some hydrogen atoms they do not have neutrons at all, zero neutrons in hydrogen atoms. But very few atoms of hydrogen they contain one neutron in them in their nucleus, and some more hydrogen atoms they contain two neutrons also in their nucleus. In this way, the number of neutrons in the atoms of an element vary from atom to atom. Those atoms which are having different number of neutrons in their nucleus will get different mass numbers, but they belong to same element. Such kind of atoms with the same atomic number but different mass numbers are considered as isotopes. Okay. Further research has proved that within the atom there are over 100 different kinds of subatomic particles. Okay, now till now we have discussed about three important and fundamental particles of atoms. They are electrons, protons and neutrons. In fact, actually inside the atoms, not only these three particles, there are over 100 different kinds of subatomic particles inside the atom. So out of these all 100 kinds, the important and most stable particles are these three, electrons, protons and neutrons. The remaining all particles are also called as subatomic particles. Subatomic particles means the particles which are present inside the atom. By the division of atom, we get dissolved particles. That's why they are called subatomic particles. So apart from these three important particles, if you can see some more like positrons, mesons, neutrinos, etc. These all come under subatomic particles. But mostly, most stable and mostly existing particles with considerable properties are electrons, protons, neutrons only. That is why these three are specially called as fundamental particles of matter. Okay, in the earlier days, they considered as atoms as the fundamental particles. They thought at the time atoms are the smallest and indivisible particles. But after the discovery of these particles, these became the fundamental particles. Okay. Now, let us see the comparison of properties of electrons, protons, and neutrons. Okay, let us see the comparison of the properties of these three fundamental particles through a chart. See here, generally electrons are represented with the small e, protons with the small p, and neutrons with small n. And the charge of electrons. If you observe, the charge of electron and proton, quantitatively both are equal, which is equal to 1.602 into 10 to the power of minus 19 coulombs. But they are opposite in charges. Electrons are having negative charge, whereas protons are having positive charge. But quantitatively, both are equal, but just a difference in the charge. And relatively, as the charge, this is the smallest charge existing on any particle. That is why it is considered as one unit. The charge of electron is considered 1 unit, and it is being negative, it is called negative 1 unit negative charge. And the same quantity of charge is there in the proton also, which can exist on any smallest part, any particle which is smallest. That is why this is also considered as 1 unit charge, and for proton it is positive. So we can say the relative charge of electron is -1 and that of for proton is +1. And next, by coming to neutron, the charge of neutron is 0. It has no charge. Okay, it is a chargeless particle among three fundamental particles. Next, by coming to mass, if you see, mass of electron is 9.11 into 10 to the power of minus 28 grams, whereas the mass of proton is 1.672 into 10 to the power of minus 24 grams. Of course, here they have given the kgs. If you see the mass of neutron also 1.674 into 10 to the power of minus 24 grams. So mass of proton and mass of neutron are almost nearly equal. If you see accurately, the mass of neutron is slightly greater than that of proton. But when you compare the mass of electron with mass of proton and neutron, it is completely negligible. Mass of electron is negligible when compared to the mass of proton and a neutron. Okay, if you see the same in AMUs, atomic mass units, mass of electron we get it as 0.00054 AMU. For proton it is equal to 1.00727 AMU, whereas for neutron it is 1.00867 AMU. See, it is being a little greater than that of proton's mass, isn't it? But relatively, if we take approximate values, for electron we can consider it as 0 when compared to mass of proton and neutron, and the mass of proton and neutron are taken as 1 unit, that is 1 AMU. Okay, approximately. These are the properties of three fundamental particles. Now let us see the structure of an atom and different atomic models which are explaining about the structure of atom. Dalton's atomic theory suggested that atom is indivisible and indestructible, isn't it? That was a first theory which explained the structure of atom. That is Dalton's atomic theory. In that, it was proposed that atoms are indivisible and indestructible. But the discovery of these two fundamental particles, mainly electrons and protons, present inside the atom, the failure of this aspect of Dalton's atomic theory, isn't it? By the discovery of these fundamental particles, electrons and protons, the concept which proposed by John Dalton was failed. It was then considered as it is necessary to know how particles are arranged within an atom. Okay, they have discovered the fundamental particles related to this Dalton's atomic theory. As they have discovered those, then they try to explain how these particles are existing inside the atom. Yes, there are electrons and protons in the atom. If there are, how they are existing? Are they being all together? Are they mixed? Are they arranged in any systematic arrangement? So in this way, they have tried to explain the arrangement of these fundamental particles in an atom with different atomic models. So for explaining this, many scientists proposed various atomic models. Out of those all, J. Thomson was the first who proposed a model for the structure of an atom. So many scientists they have tried to explain the structure of atom. That means the arrangement of fundamental particles in an atom. Out of those all, J. Thomson was the first who proposed a model for the structure of an atom. That is we say as Thomson's atomic model. Thomson during this research discovered a particle which was electrically charged and has mass equal to 1 by 1837 times that of mass of a hydrogen. The charge on this particle was negative. So these particles were named as electrons later, isn't it? Thomson discovered these electrons. He called those particles as cathode rays. Later on, the name electron was given for these cathode rays by J.S. Stoney. These are negatively charged particles and their mass is very small. It is nearly equal to 1 by 1837 times to that of hydrogen mass. Okay. Further experiments proved that all elements are composed of electrons and protons. So after the discovery of these fundamental particles, electrons and protons, the further experiments proves this, as all the atoms are consisting of these electrons and protons in them. However, no two elements have same number of protons. Each and every element is having a fixed number of protons which is entirely different from the remaining. If we see hydrogen, it will be having only one proton. If we see helium, it will be having always two protons. So the number of protons are being different from one atom to another atom. So for example, the number of protons in first few elements are mentioned here. Say helium has 2, beryllium has 3, beryllium has 4, boron has 5, carbon has 6. In this way, for some elements are given here. We can understand from this the number of protons in an atom for an element is being fixed, which is different from the remaining elements. Okay. Furthermore, it was assumed that the number of electrons in an atom is equal to the number of protons. Yes, further, based upon the electrical neutrality of atoms, this proposal was given. It is assumed that for any atom, number of electrons is equal to number of protons, as the atoms of any element are being electrically neutral. However, the question arises about how the electrons and protons are arranged within an atom. So there are protons and electrons in an atom. If there are, how they are existing inside the atom? That is the question here. Especially negative charges on the electrons attract positive charges on the protons. So if these are being attracting each other, how these are existing inside the atom without collapsing? This doubt led to the suggestions like atomic models. Okay, J. Thomson at that time proposed an atomic model which is called as watermelon model or apple pie pudding model, or which is also known as plum pudding model of the atom. In this way, he compared the atomic model with watermelon. That's why his model is also called as watermelon model. Okay. According to this model, an atom is made up of positively charged substance which is spread very thinly in the form of a sphere. See, as shown here, the entire positive charge in an atom, it is spread in like a sphere shape. Into this sphere, negative charged particles, that means electrons, are embedded. This as shown here. So this can be compared to a watermelon, in way which has evenly distributed red spongy pulpy mass with black seeded seeds embedded in it. See here how it is. Watermelon we know as it is containing red pulp completely spread over in the sphere shape. In that there will be black seeds embedded in it. In the same way, he explained the structure of atom also. the total atom will be in the spherical shape, which is completely filled with positive mass, and the negative charged electrons are embedded in it. In this way, he explained the structure of atom by comparing with a watermelon. That's why his model is also known as watermelon model. Okay, this was the first atomic model which was given by J. Thomson. Okay, let us see further models in the coming classes. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.